Welcome to The Explainer. I'm so glad you're joining us today because we're going to unpack a massive hidden infrastructure problem that is literally right beneath our feet. Think about it for a second. Every time you turn on your tap, clean, perfectly treated water flows out. It's basically magic, right? But have you ever stopped to wonder about the incredible labyrinth-like journey that water took to get to your glass? And honestly, more importantly, have you ever thought about how much of that water never actually makes it to its final destination? Let's dive into this, because the sheer scale of this hidden problem is wild, and it definitely demands our attention.
So, what actually happens when perfectly treated water just disappears? Imagine you're carrying a heavy bucket of clean water all the way across your yard, but a third of it vanishes through a hole in the bottom before you even get there. All that effort, all that energy, just totally wasted. Well, that leaky bucket analogy is exactly what happens every single day in water distribution networks all around the world. Today, we're going to look at how the water utility industry tracks this invisible drain and what fixing it actually means for resource conservation and, of course, the bottom line.
All right, here is our game plan for today. First, we'll look at the hidden infrastructure problem. Second, defining non-revenue water. Third, the cost of doing nothing. And fourth, fixing leaks and building value. Let's get right into it.
Okay, Section 1, the hidden infrastructure problem.
Now, as we know, water utilities don't just magically pull water out of thin air. They build, operate, and meticulously maintain incredibly complex, interconnected networks. We're talking extensive pipelines, miles of canals, massive reservoirs, and high-powered pump stations. It's a total engineering marvel, operating 24/7, mostly out of sight underground. But despite all that robust engineering, these systems are highly prone to failures, and this leads to real water losses. We're talking about leaking pipes, some of which have been buried for decades. We've got faulty service connections, right where the main line meets a neighborhood or a house. And sometimes we're even dealing with storage tank overflows. Basically, these are physical failures where tangible, usable water just escapes the system before it can ever be used.
Moving right along to Section 2, defining non-revenue water.
The industry officially defines this disappearing act as non-revenue water. By definition, this is the physical water lost from the pressurized system and storage tanks before it ever reaches the billed customer. Think about what that actually means. A utility spends a fortune to source the water. They spend money to filter it, chemically treat it, make it perfectly safe. Then they spend even more money pumping it into the pressurized distribution system. But because of those leaks and overflows we just talked about, it never reaches the customer's meter. It produces absolutely zero revenue. It is effectively a total financial and physical loss for the utility.
Which brings us to Section 3, the cost of doing nothing.
You might be thinking, well, if the water is just going back into the ground, what's the big deal? It's a huge deal because it creates a massive ripple effect. First off, physical water is lost. We're in an era of increasing water stress, and a precious natural resource is simply being wasted. Second, the immense amount of electricity used to push that heavy water through miles of pipelines, completely wasted. Third, the expensive treatment chemicals used to purify the water are squandered. And finally, step 4, customer rates go up. Utilities operate on a margin, right? So all those squandered resources get passed directly on to everyday customers through higher bills. It's literally a direct line from an infrastructure failure straight to your wallet.
And that leads us to our final part, Section 4, fixing leaks, building value.
So how do utilities actually track, manage, and solve these inefficiencies to stop this massive drain? Really, it comes down to proactive planning versus reactive fixes. On one hand, you have planned maintenance, regular activities undertaken before an asset fails. On the other hand, you've got corrective maintenance. This essentially means waiting for a pipe to burst and flood a city street before anyone fixes it. Utilities face huge challenges when deciding how to deploy their capital between these two approaches. They're constantly battling the chemical impacts of corrosion, shifting soil properties that eat away at cast iron or PVC pipes, and honestly, just the sheer age of their current distribution networks.
To keep utilities accountable, investors and regulatory bodies track two really important quantitative metrics established by the Sustainability Accounting Standards Board, or SASB. The first one is the water main replacement rate. The second is the actual volume of non-revenue real water losses, which they measure in thousands of cubic meters. Now, these aren't just dry, abstract numbers. These are the core vital signs of a water utility's operational health. By tracking these specific metrics, you can clearly see if a utility is actively improving its network or just letting it slowly decay.
If we look a little closer at that first metric, the water main replacement rate, there's a really important catch. It strictly excludes mere repairs. Pouring money into temporary, band-aid fixes on an ancient, crumbling pipe doesn't actually solve the underlying problem, so it doesn't count. To count toward this metric, a utility has to perform complete main replacements, or major renewals, that fundamentally upgrade the infrastructure and substantially extend the pipe's life. It's a metric that demands real, long-term capital investment, not just a quick patch job to get through the week.
And this all builds to our main takeaway today. Efficiently directing capital to fix pipelines and service connections isn't just some kind of environmental charity. As the SASB standards clearly point out, limiting non-revenue losses is a core business strategy designed to improve entity value and provide strong investment returns. When a utility actually stops the leaks, they increase their effective revenue, they drastically reduce their wasted energy and chemical costs, and they build a financially stronger, way more resilient organization. So conservation and financial performance are, in this case, completely aligned. It's a win-win.
We literally rely on this hidden infrastructure for our very survival, yet it is so easy to ignore it until a pipe bursts. After seeing how non-revenue water impacts everything from squandered energy to the bill you pay each month, I really want you to ask yourself, is your local utility tracking every drop, or are they just letting value slip through the cracks? Thank you so much for joining me for this explainer, and I hope you never look at a glass of tap water quite the same way again.